In this video, I'll show you how easy it is to build comprehensive IoT solutions using WiNoT. Although these demos are very simple programs, after showing the demo for all these programs, I will tell you about what makes WiNoT special and how you can actually use the same concept to build real IoT solutions. In the first example, I'll show you how to integrate a touch sensor with a buzzer to create a doorbell. The touch sensor responds to human touch and gives a reading based on whether it's been touched or not. First of all, in the demo application, I'll click on the doorbell button. By doing this, I've started the WiNoT board to act as a doorbell. When I go and touch the sensor, the buzzer starts to beep, or I could say that the doorbell starts ringing. Now let's see the code for this application. First of all, I define the push button and the buzzer objects by specifying their address. The while true statement means that this part of the code will run continuously from now on. Code first checks if the touch sensor was touched. If true, then it calls a function to ring the bell. So once again, with simple lines of code, we can get our work done. In the next example, I will control an LED based on the ambient light intensity. So this is like a smart light which can be turned on or turned off based on the ambient light conditions. In this example, I've used an LED. But in real application, you could replace the LED with an actual bulb connected using a relay. First of all, I'll start the board in Smart Light mode by clicking on the Smart Light button on the demo application. When I start the application, the LED starts blinking. To understand why it started blinking, let's take a look at the code. So the code here first checks for the ambient light intensity. If the light intensity is between 2 and 3, the LED is set to blinking mode. As we've seen in the demo about the LDR, the ambient light level is 2, and that's why the LED is blinking. Then the code checks if the intensity is 0 or 1, then the LED will be fully turned on. When the intensity is 0 or 1, it means that the ambient light conditions is quite dark. If the intensity is greater than 3, then the LED is completely turned off. So let's get back to the application. I'll now cover the LDR completely so that the light intensity is 0. Now the LED is turned on. I'll now show a flashlight on top of the LDR, and this time the LED completely turns off. You see how we've been able to build a smart lighting switch with just a few lines of code. Finally, we'll see a more complex system which uses 2 sensors and 2 output devices. First of all, let's start the board as an intruder alarm. So I'll move my hand very close to the board. When I do that, 2 things happen. First, the LED turns on and then the buzzer starts beeping. Now I'll move my hand but at a little distance away from the board. This time the application detected that there was some motion, but it was not at a very close distance. Hence, the LED just started blinking without sounding the buzzer. Let's see the code for the intruder detector to understand more. Again, the entire intrusion detection system has been built in around 20 lines of code. First of all, we create an object for each of the sensors and the output devices. Then the code checks whether there's any motion in front of the board. If and only if there is a motion in front of the board, we measure the distance from the nearest obstacle. If the distance is greater than 20, then it makes the LED to blink. If the distance is between 10 and 20 centimeters, then it turns on the LED. If the distance is less than 10 centimeters, then it turns on the LED and also turns on the buzzer to indicate a more serious alarm condition. One big question that is probably crossing your mind at this time. Now we have a board and we've used 4 devices from this board to build a smart system. How am I going to implement a more complex system with just this one board? What if I want to have the motion detector, the distance range, the LED and the buzzer to be located in different places? Well, here's what makes WiNoT versatile. Just look at the part of the code in which we define the objects. The first line says LED equals YLED bracket trainer address. The second line says buzzer equals YBuzzer bracket trainer address, and so on for the 4 objects. Now in this example, all the 4 of them have the same address, which is the trainer address. That is because we are using the same board for all of these sensors. In a real life scenario, each one of these devices can be connected to different boards, and in this case, each one will have different addresses. For example, you could have the motion sensor fixed in one place and the distance measure fixed at another place. And you could also have the alarm light or the LED in one room and the alarm buzzer in another room. So all of these 4 devices are in different locations and each one of them are on a separate board. And obviously each one of them have a separate network address. Also remember that I ran the program from my laptop and there is no wire between the laptop and the board. The only link between the WiNoT board and my laptop is that both of them are connected to the same wireless network. Even if there are many more devices connected to the WiNoT boards, we can still build full-fledged IoT systems by writing simple Python codes, which is what the WiNoT trainer kit and the tutorial will help you accomplish.